Alright, our second day of 8.6. Today we're going to solve log equations instead of exponential equations. And before we get to solving, let's review. If I've got 7 raised to the log base 7 of 6, that's 7 log 7 cancels, and this just becomes 6. For number 2, 5 raised to the log base of 5, likewise, cancels, and we get x. Number 3, we've got 10 raised to the log power. Now since that log does not have a base written, we assume that's the common log, which has a base of 10. So that cancels, and there's no number there, it's just 1. Alright, so we're going to use that idea to help us solve log equations. And for log equations, we have to make sure that we check our answers, because they're not always going to work. So for number 4, we've got log base 2 of x is equal to a negative 1. I want to get to x, and I want to get rid of that log base 2. So the way to get rid of that log base 2 is if I have 2 raised to that power. And if I do that on the left side, I have to do that on the right side. So this becomes 2 raised to the log base 2 of x, which is equal to 2 raised to the negative first power. That cancels, so x is equal to 2 to the negative first power. You can type this into your calculator, or you can know that that negative means that we take the reciprocal, which becomes 1/2. We check our answer. Make sure that you're going back to the original. So we've got log base 2 of 1/2 is equal to a negative 1. A bunch of different ways you can check this. You can do the change of base in your calculator, or you can rewrite it as an exponential equation, which would be 2 to the negative first equals 1/2, which is correct. Number 5, I want to get to the x, and that's inside of the 8 natural log of x. So first I want to isolate that term, so I move the 2 over. 8 natural log of x is equal to 28. Now that 8 is not inside, it's just the natural log of x, so I divide by 8. And we get the natural log of x is equal to 3.5. As we talked before, you have the option of keeping it as a fraction or a decimal as long as your decimal is an exact answer. Remember, if this was a third or some other fraction that does not come out exactly, you would have to keep it as a fraction. Alright, so I want to break apart the natural log and the x, so I want to get rid of the natural log. And we know that to get rid of the natural log, we use the e function. So e raised to the natural log of x. If I do that on the left side, I have to do e to the 3.5 on the right. E natural log cancels, so we got x is equal to e raised to the 3.5 power. And you can just put that right into your calculator. And we get that x is about 33.115. Just like before, we have to check this. Now we want to be careful here. In number 4, we had an exact answer of 1/2. In number 5, we're rounding. So you've got to expect that it's not going to be 100% exactly the same. Because we rounded, you're going to have rounding error in your answer as well. So we replace that with 33.115 is equal to 30. And when you enter this in your calculator, 2 plus 8 natural log of 33.115. We get that equals 29.9998. And that is going to be good enough to say, yes, this is a solution, it does work. Because remember, that rounding error is going to account for that small margin that it was off. Now if it was 28 equals 20, or 28 equals 30, that wouldn't work. Number 6. We've got log base 2 of 3x minus 5 is equal to log base 2 of x plus 13. You can instill that same idea that we've been talking about, that to get rid of the log base 2, you raise everything, or have it a base of 2, and you raise it to those powers. And you see that that cancels, and you're left with 3x minus 5 is equal to x plus 13. there's actually a shortcut that you can skip this step. Since we have log base 2, and we've got those two pieces equal to each other, just like we talked about yesterday with the exponents, if the base was the same, here if the log is the same, then those quantities must be the same. The log base 2 of 5 is not the same as log base 2 of 4 or 3. So these numbers must be the same in order for the equations to be equal to each other. And that way you can skip that middle step and you can go directly to saying 3x minus 5 equals x plus 13. Move the x over. 2x minus 5 is equal to 13. Add 5. Divide by 2, and we find that x is equal to 9. We check our answer. So we've got log base 2. 3 times 9 gives us 27 minus 5 equals log base 2. 9 plus 13, 22. 27 minus 5. We get log of 22 equals log of 22. So our solution works. Number 7, we have log of 5x plus log of x minus 1 is equal to 2. Now this is a problem where you have to use all of your properties with everything else you know about logs. As soon as I see this plus sign, I know that I was originally multiplying. With number 6, I have a log on the left side and a log on the right side. Number 7, since I have logs on both sides, and both of those logs are the same, I want to condense it together. It's just like adding like terms. Before you solve, you add like terms. So this really is log of 5x times x minus 1 equals 2. Now this log, again, if you remember, is the common log. If there's no number there, then it's just really 10. So to get rid of that, I've got 10 raised to the log base 10 of 5x x minus 1. So on the right side, I take 10 to the second power. That cancels. 5x times x minus 1 gives you 5x squared minus 5x. On the right hand side, 10 squared is 100. Now we have got a squared and x, and we've got a quadratic, so you know to solve this we're going to have to factor. So we've got 5x squared minus 5x minus 100 is equal to 0. When you factor this quadratic, the first step of factoring, hopefully you remember, is pulling out your GCF. And make sure that you pull that out of each of your pieces. So now I'm looking for two numbers that are going to multiply to 20 and add to a negative 1. So it's x minus 5 and x plus 4, which means I have two possible solutions. This is x equals a positive 5, and this is x equals a negative 4. So we've got two solutions that we need to check into our original. So we've got log of 5 times 5, which is log of 25, plus log of 5 minus 1, which is 4, equals 2. And that's log 25 times 4 is log of 100 equals 2. Remember that base, and that's going to be the same, because 10 squared gives you 100. So let's check our second answer of negative 4. So I've got log of 5 times negative 4, which is a negative 20, plus log of negative 4 minus 1 is a negative 5, equals 2. Now this is not going to work. If you pull out your calculators, I know negative 20 times negative 5 gives you a positive 100, but if you try typing this into your calculator before you combine, take log of negative 20, just that one little piece, and you hit enter, you get an error message. This answer cannot be negative. So anytime you have a log of a negative number there, that's not going to be possible. So this one does not work, which means negative 4 is not a solution. So you have one solution at 5. 2 problems left. Number 8, we've got 3 minus 2 times the log base 3 of x is equal to a negative 7. I want to get that x alone, so just like if it was anywhere else, you follow the same rules. First thing we do is subtract the 3. Negative 2 log base 3 of x is equal to a negative 10. I want to get that log alone, so I divide by a negative 2. Log base 3 of x is equal to 5. Okay, so far everything on the left is locked in. I've got log base 3 of x. I can't separate those. Equals 5. So to get rid of that log base 3, I take 3 raised to the log base 3 of x, which means on the right hand side I've got to do 3 to the 5th power. 3 raised to the log base 3 cancels, and we're left with x is equal to 3 to the 5th, which is 243. We check our solution. 3 minus 2 times log base 3 of 243 is equal to a negative 7. Again, if you plug this into your calculator, 3 minus 2, you'd have to change this to log of 243 divided by log of 3. You will find that it does equal a negative 7. Last problem for today. Number 9, we've got log, or natural log of x plus 5 equals natural log of x minus 1 minus natural log of x plus 1. So on the left hand side we've got natural log of x plus 5. On the right hand side I've got two pieces that have the same base, and that subtraction sign means that they were dividing. So this is really the natural log of x minus 1 divided by x plus 1. The next thing that you need to see here is they both have natural log. Since there's a natural log piece on the left side and the natural log piece on the right side, and there's nothing else, in order for those two pieces to actually be equal, like our equal sign says, then those numbers inside have to be equal. So I can skip that step of doing e raised to the natural log power, and I can just do x plus 5 has to equal x minus 1 divided by x plus 1. Now don't get me wrong, you can go ahead and say e to both sides, and that cancels, and then you just end up at that step. So that's just a shortcut of skipping that one step. Alright, I've got a fraction on the right and on the left, so I make the left hand side into a fraction by putting it over 1, and we cross multiply. So we've got x plus 5 times x plus 1 equals x minus 1. FOIL to get x squared plus 6x plus 5 is equal to x minus 1. Move everything to one side so we can solve our quadratic. That becomes a positive 5x, a positive 6 equals 0. So I'm looking for two numbers that are going to multiply to 6 but add to 5. That's 3 and 2. So we've got two possible solutions, one at a negative 3 and one at a negative 2. So we go to check. We've got the natural log, we plug in a negative 3. Natural log of 2 equals natural log of negative 4 minus natural log of negative 2. As soon as you see the natural log of a negative 4, just like in the last problem, that's not possible. So this one's not going to work. We move on to our next possibility. We plug in the negative 2, that gives me the natural log of 3 equals negative 2 minus 1, negative 3, negative 1. Once again, we've got these negatives with our natural logs, which means they're not going to work, which means that one doesn't work either, which means there's no solution. So both possibilities didn't work. And we're done.